afternoon, everyone. Welcome to yet another lecture of the course titled Artificial Intelligence in Industrial Management Engineering, Applications of it. I am Professor Deepa Philip. I am from IIT Kanpur, and this is part of the NPTEL MOOCs course on AI applications in industrial management engineering. And we have gone through multiple aspects of industrial engineering. We have also seen the basics of AI. And compared to the continuing with the last lecture where we were looking at this example. So, if you look into the screen, you can see that we were trying to work on a hands-on exercise. Okay. In this hands-on exercise, there are 5 movie critics: Ram, Sita, Matthew, Geeta and Jenny. And there are 5 movies: Star Wars, it's called as A, Star Wars, Raiders of the Law, 4 movies, A, B, C, D. Okay. Roman holidays, and they are given different ratings. Star ratings are given by the critics about different movies. So, the 2 questions that we wanted to do or we wanted to work in, the first question is how can an algorithm use this data set to recommend the movies? That is the first question. Second one is how would you do it? If you have to do it by yourself, how would you do it? So, without delaying much, let us get into the question. So, the first option you can think about it is similarity in taste. That is the logic. So, one way to think about it, if you look at the data, the critic Ram liked Star Wars and Raiders of the Lost Ark. You can see he has given a 4 star and 4 star and given 1 star to Casablanca and 2 star to Roman holidays. And Sita, you can see that she has given 5 star to Star Wars and 4 star to Raiders of the Lost Ark and has given 2. So, the logic here is you can say that by looking at the data, people who liked Star Wars are in close in preference space to people who liked Raiders of the Lost Ark. So, you can see that the people who liked Star Wars, Ram had 4 rating, there is also 4 rating, 4 and 4. Sita had 5 rating with Star Wars, but her rating is also 4 for Raiders of the Lost Ark. So, you can see that the 4 and the 5s are close enough to each other. So, if that is the case, if I draw in one axis, let us take Star Wars, another axis, let us take Raiders of Lost Ark, have 0, 1, 2, 3, 4 and 5, 0, 1, 2, 3, 4 and 5. So, if I take that, so then you can see that Ram, if you take Ram had given 4 to Star Wars, this is 4 to Star Wars and 4 to Raiders of the Lost Ark. So, the intersection point 4, 4 is Ram. Let us take Sita, who has given 5 to the Star Wars, which is here, and 4 to the Raiders of the Lost Ark. So, this place is Sita. Okay. So, you can see that Ram and Sita had given very similar preference, they are close to each other. Now, let us look at the third one, which is Matthew, who has given a rating of 2 to Star Wars and 2 to Raiders of the Lost Ark. So, if we take this intersection, this is Matthew, and let us look at Geeta, who has given 2 to Star Wars and 1 to Raiders of the Lost Ark. So, this is Geeta. Okay. So, you can see that Matthew and Geeta had also have a similar aspect. So, now the question is Jenny has given a rating of 5 to Star Wars. Okay. So, Jenny's rating is here to Star Wars, okay, like this. So, where would she fall? Okay. The question is, what would be her rating here? What will be this? Yeah. So, you can say that it can be anywhere here, but given that Jenny gave 5 stars to Star Wars, she has a high chance of giving 4 or 5 rating to Raiders of the Lost Ark. So, by going by the data we have, we can say that Jenny could be here or Jenny could be here. She can give a, this can be either Jenny or this can also be either Jenny. Okay. Worst case scenario, she may even give 3, but this logic of her being here, this is in another way to think about it is, they are similar by taste in movies. So, this is how an individual as a human being you would end up doing that part. And similarly, if you look into it, this is the other cluster, other similar group. I do not want to use the word cluster at this point yet. Okay. So, we can see that. Okay. Fair enough. So, now this is how as an individual, this human brain identifies patterns in this fashion. We usually do this without even thinking about it. Now, how would an algorithm do it? So, measuring similarity in an algorithm would be the, let us take an approach 1. Okay. Let us take the first approach, measure similarity by using Euclidean distance. Okay. So, what is Euclidean distance? So, let us say you have x, y and you have one point which is x1 comma y1, another point which is x2 comma y2. So, then this distance, this is the Euclidean distance. Okay. So, this is, let us call it as I and j, I, xi, yi and xj, yj, then dij. Okay. So, this is your point I, this is your point j. Okay. dij, distance between point I and point j, which is equal to the Hero's formula xi minus xj the whole square plus yi minus yj the whole square, okay, and under root. So, this is the Euclidean distance measure. Okay. So, if you think about it, in the previous example, okay, we had, okay, Star Wars, Raiders of the Lost Ark. So, you had at one place Ram and Sita. So, you can measure the Euclidean distance between them. Another place you have something like Matthew, Geeta, measure the distance between them, and you can also measure the other distances as well and find the ones which are shorter to each other. Then if you use Euclidean distances, so the logic here is, how would you make a recommendation? Jenny has not seen the Raiders of the Lost Ark. Okay, that we know. She has seen Star Wars and rated it with 5 stars. Hence, it is safe to bet that Jenny will like Raiders of the Lost Ark. So, as I said earlier, the data, we can say that in the Star Wars and Raiders, you have Matthew, Geeta in one side, and you had Ram, Sita in another side. So, this is people who liked Star Wars and also liked Raiders of Lost Ark, and this is liking of Star Wars. This is 5. This is 1. Not liking Star Wars. Okay. And same way, this is 1 and 5. Okay. So, the logic here is that the Jenny's Star Wars rating, that is 5. So, it is safe to assume that Jenny will also fall in this cluster. So, that is what we tried to explain so far. Okay. So, now continuing this, we would like to know, so what we are doing is we are talking about features, identifying features from the data. Okay. So, point number 1, features from data were used to compare critics. Okay. Critics, there are 5 movie critics, say all 5. Okay. So, what is feature? When you say feature, what is it? What is feature? Okay. It is a data attribute. It's a data attribute that can be used. To make a comparison. So, you can use this data attribute. Okay. It is a data attribute that can be used to make a comparison. Now, quantify attributes of an object, so that computer can understand. So, the critical is if you can quantify the attributes of an object. Okay. If so that, then it is easier for the computer to understand. So, what are some of the quantifications? One is size, another is weight, color, shape, etc. Okay. So, if we can quantify any of those attributes of an object, so then computer can easily understand. Also, quality of the chosen feature is important. Quality means how well the attribute differentiates. So, choose an attribute, that quality which is able to very well differentiate the aspects about an object. That is very critical in this regard. So, as we said, what is a feature? Feature is a data attribute that can be used by the computer to make a comparison, and some of the attributes that can be quantified, size, weight, color, shape, etc. But also choose the attribute that has good quality. Quality means how it can differentiate, how well it can differentiate. So, let us talk about good features. When people say I am using good feature or extracting good feature from the data, what does it mean? Let us talk about what we are talking about there. Okay. A good feature is the one that can discriminate between classes. Okay. So, good feature is the one that can discriminate between classes. Okay. It allows the discrimination between classes. So, skill to be developed. Okay. A critical skill that need to be developed. How well does a feature help us to tell two things apart? Okay. How well, you have to be able to judge. Okay. You should be able to gain that capability to judge how to tell two things apart. Okay. So, some questions for you. Is mass of an object is a good feature by itself? Okay. Is the mass of an object is a good feature by in itself? Is it a good feature? It is mass. Is it a good feature when used in conjunction? Okay, with another feature like color. Okay. So, let us think about the third question. Is density a better feature? Okay. Just throwing questions in this regard. So, like we can think about, is mass of an object a good feature by in itself? We just consider mass, is it good? If not mass, is it a good feature when you conjunct it with the feature like color, mass and color combined together, or mass or color or combined mass or color, is density is better than that? Okay. So, this is an interesting point, and let us see how we do this. Okay. So, let us take this previous movies. Okay. So, let us take some few features. Okay. In Star Wars. So, first one is I am going to give certain data points. Year of the movie Star Wars. It was in 1977 and Raiders of the Lost Ark was 1981. Casablanca was in 1942 and Roman Holiday was in 1953. Okay. Then let us take the other one is the length of the movie, okay, in minutes. This is 121, 115, 102, 118. Okay. So, these many minutes is the length of the movie. Main actor is another one. Okay. This is Harrison Ford. Again in Raiders of the Lost Ark. Casablanca, Ingrid Bergman. And this is Audrey Hepburn. Okay. Audrey Hepburn. You can look at these movies, you will get some of these features. Okay. Then we talk about it as whether it is an action movie on a scale of 1 to 5. Okay. This Star Wars is an action movie on scale of 1 to 5. Raiders of the Lost Ark is a scale of 1 to 4. Casablanca 2. Roman Holidays was a romantic comedy, so its action is 1. Then let us take romance. Again 1 to 5. Star Wars 1. Raiders of the Lost Ark I will give it as a 2. Casablanca is 4. This is 3. So, if I am just giving you like 5 features, okay, feature 1, 2, 3, 4, 5 and the same values are given. So, first critical point that you should understand is or you should know is that developing a good recommendation system. Developing a good recommendation system requires data having good feature set. Okay. So, you require good feature set, a data with good feature set if you want to develop a good recommendation system. Okay. So, then question is where will I get the data, okay, or who will give me the data? The critical question is where will you get that data or who will give you that data? That is the most important aspect. The logic is you have to have a good feature set, but who will give you that data, and that is very critical at this point. Okay. So, now let us get into that point called clustering. Okay. And this is I am trying to explain to you what we have done so far is clustering. So, remember that it is unsupervised learning. Okay. But remember that it is unsupervised learning. Okay. So, what is the importance of unsupervised learning? We had mentioned this in the previous class. Okay. The main thing was that unsupervised learning, if you go to this supervised learning, the main thing was data is labeled. Okay. Unsupervised data is unlabeled. Okay. So, we are talking at this point that clustering is working on is an unsupervised learning, which means unlabeled data. So, what is cluster? The question is what is a cluster? Okay. The answer to that it is a group of related objects. Very simple. Okay. The previous one what we said is, if you go back, you can see that Ram, Sita and Jenny, okay, this is a group of related objects. Then humans can cluster small number of objects. Okay. So, they can cluster small number of objects. This is true. Okay. But what happens when the numbers are large? When the number of objects are large. Question is what happens. Okay. Second thing is, what if more than one parameter is to be used? The two critical question is, as a human being, you can cluster small number of objects. We just did 5 movie critics on 4 movies. We could easily do that. But what happens when the number of objects are large and when you have more than one parameter to be used? Okay. So, this is where you require a computer algorithm. Okay. So, one such popular algorithm is K-means. Okay. In 1967. Okay. Can find clusters automatically. We can find clusters automatically with these things. Okay. And the main thing is, main consideration here. Okay. The algorithm can be taught. Algorithm can be taught. We can teach the algorithm. But how will you convert the knowledge of algorithm of K-means into a skill? This is something that you need to think about. You can teach the algorithm, but how will you convert that into a skill? Okay. So, what I am going to do is, I will today's lecture, the last slide will be the introduction to K-means algorithm, and we will talk about how, or we will think about how to convert it into a skill. So, as I mentioned earlier, the K-means algorithm developed in 1967. Okay. So, let us go through that algorithm very quickly. It is very simple steps. First one is, choose K starting points randomly. Okay. Randomly. These starting points are known as centroids. Okay. So, you can choose K starting points randomly, the choice is randomly, and these starting points are known as centroids. Okay. Then number 2, calculate the Euclidean, I mentioned this Euclidean distance between each point and centroids. So, you calculate the Euclidean distance between each point and centroids. If you have 5 points and you have chosen 2 centroids, so then each of the 5 points you will calculate the distance between the centroids. Then group each point according to the nearest centroid. Okay. So, one of the simplest way to do it is group each point according to the nearest centroid. Okay. So, you have to group each point based on the nearest centroid. Then 4, recalculate the mean of each centroid as the mean of the points of the same group. So, what you do now is you have randomly chosen the starting points, centroids. Then once you grouped each one of them to the nearest centroid, then you recalculate the mean of each centroid or calculate the center point of each of those cluster as the mean of the points of the same group. So, whatever the points comprising of the group, take that and find the mean of it, okay, or center of gravity of it. Then 5, move the centroid to the new mean location. Okay. So, once you calculate the mean of the centroid, you move the centroid to the mean of the new location. Okay. Then 6, repeat previous steps until centroids remain stationary. Okay. Stationary means, so you repeat these previous steps until centroids remain stationary, which means no move or no change in the centroid. So, this is the K means clustering algorithm. So, you choose K starting points, you choose them randomly, and these starting points are known as centroids. Okay. And for each point and the centroid, you calculate the Euclidean distance, and based on the Euclidean distance, group each point according to the nearest centroid. So, the Euclidean distance will tell you where is the nearest centroid, and then once you made that cluster, you calculate the mean of each centroid as the mean of the points of the same group. So, you find the center of gravity of all the points in one cluster, and that is updated as the centroid. So, then you move the centroid to the new mean location, and you continue to do this, and at some point of time the centroids will not move, they will remain stationary. Then last step is, when centroids become stationary, stop and report the clusters. Okay. So, once these centroids have become stationary, you stop the process and report the clusters, the details of the clusters. Okay. So, with that we have come to the end of the today's lecture, and we have quickly gone through the basics of AI and some aspects of ML and types of learning, supervised, unsupervised, semi-supervised, all those things. And we have taken a small data sets, identified what is a feature, how to use feature to classify or identify or distinguish different objects. And then we also saw a very simple algorithm, it is called K means algorithm, just went through that. And we also discussed how to convert this knowledge of this particular algorithm into a skill, and we have not gone through that, but we will go through that in the next class. In the meantime, please think about what we have discussed in the class and try to do your self learning. I will come back and see you guys soon, tomorrow, day after, with a new topic. Thank you very much.